Okay, so finally onto your grade 11 analytical geometry work. The concept we'll be focusing on is angle of inclination. Right, so basically when you think about inclination, you think about the word incline, and that's exactly what angle of inclination is. It's testing out what is the incline of a line from a flat normal, right? And that normal will be my x-axis. Right, so if we have a line intersecting your x-axis, we are finding out what is the angle of that line, or at least the incline of that line, right? And we'll always draw from the x-axis to that line. This over here will be your angle of inclination, right? So you see that I'm going from this positive x-axis side to my line, and the reasons for that is basically, well, from trigonometry. If we look at a cast diagram, we know we usually say 0 degrees there, 90 there, 180, 270, and ending back at 360. So working from that 0 to my angle, that's why we'll start on this side as well. The angle of inclination formula, or at least what we'll use to find my angle of inclination, will be as follows. We will say tan of that angle of inclination equals to the gradient of the line, and it will always be tan. Not sine, not cos, but tan. Again, stemming from trig because of opposite over adjacent, right? But we'll touch on that more when we look into trig in depth. Okay, so we know tan theta equal to the gradient of my line segment allows me to find my angle of inclination. So let's look at a few examples. Okay, so looking at an example, right? If I've got a cast diagram over there, there's my x-axis, there's my y-axis, and I have a line, straight line on that axis, right? On those axes. And the function is y equals to 2x plus 3. I want to find out what is the angle of inclination of that line. So from my x-axis to that line, over there, theta. I will then use my angle of inclination formula and say that tan of that angle of inclination equals to the gradient of that line. What is the gradient of that line? 2. So I will say tan of my angle equals to 2. Solve for theta. So all I'll do is I'll get theta alone. Arctan, tan to the minus 1 of 2. Type that in my calculator and get 63,43 degrees. Right, so that over there then is my angle of inclination. What that means is that the angle between my x-axis to the line will be 63,43. As simple as that, right? So let's look at maybe a negative line and see how that differs from, because this over here obviously being a positive line. So I'll draw the same line now, just negative. I'll say y equals to negative 2x plus 3. And what is the angle of inclination of that line? So again, we'll move from positive x-axis to my line and want to determine what that angle is over there. Okay, so same thing, I will say tan theta equals to my gradient. What is my gradient in this example now? Negative 2, right? So I'll say tan theta is equal to negative 2. Right, so just a quick note over here. Sometimes, I know some teachers, they'll say always take the positive and then adjust accordingly. I like to take the gradient as is and then make my adjustments, right? So I will put the whole negative 2 in there. I like to say that tan theta equal to m. This formula always likes to find the closest distance from the x-axis to the line, right? So when I input this in now, we'll see that I'll say theta is equal to arctan of negative 2. Type that in my calculator, I will get negative 63,43 degrees. Right, and what that actually found, that negative 63,43, was actually from this side of the x-axis, the negative x-axis, to my line. So this is actually that 63,43 degrees. Right, so remember angle of inclination is always from positive x-axis to line, so I would because it lies on my x-axis, we see that those two angles actually lie on a straight line. So whenever you are finding the angle of inclination of a negative gradiented line, or we basically end up with a negative angle of inclination, it'll be the same thing, right? All you do is you just add 180 degrees to that to find your angle of inclination, right? Angles on a straight line. So I'll say this plus 180, that will give me 116,57 degrees, right? And that will be my angle of inclination, okay? Very important for angle of inclination, we need to realize that my angle of inclination will always be at my x-axis, right? Because it's finding the angle between the x-axis and my line. So it's important to note that this really only works at my x-axis. So now I'll chat about what to do and how to use angle of inclination to find angles that are maybe not at my x-axis but still on my Cartesian plane. Okay, so looking at this example over here, I give you triangle ABC on my Cartesian plane, and they say determine what alpha is, right? And I can see that alpha lies away from my x-axis, so it's going to be a bit tough to just use tan alpha equal to a gradient, because remember that my inclination of the angle only works at my x-axis. Okay, so what you do when you need to find an angle away from your x-axis, pretty simple. We'll do one of two things, maybe three things, but one of these two things always work. Either we will create our own triangle, right, with the x-axis and use interior angles of triangle, or exterior angle of triangle, right? I find that these two work pretty well. Alternatively, you can draw an axis at the point you're looking for and then use your fun angles, you know, co-interior corresponding alternate, right? But I prefer the two, these two on top, right? And I'll show you what I mean by that. We need to remember that with inclination of the angle, we can only find angles at the x-axis, which means that I can find the angle of inclination of AB, which is there, right? I can also find the angle of inclination of BC, which is there, right? Because I have the gradients of both of those lines. AB obviously having a gradient of 2 and BC having a gradient of -3. Okay, so since I can find this angle, and let's make that angle beta, do we see that when I make a triangle with my x-axis, I'll go from B and I'll say, here is my new triangle. Let's do it like that. So I'm just trying to make it thick so you can see, right? This new triangle, I now see that B is an exterior angle of this new triangle, and I know my exterior angle is equal to the sum of my two opposite interior angles. So if I can find beta, I can find theta, I can therefore solve for alpha. Same works for interior angles of a triangle. I could have used 180 degrees, angles on a straight line to find that angle, and then use interior angles of a triangle. Right, so I'm now going to show you how to do this one. I'll do it as an example, but you will encounter similar ones when you are maybe being tested or examined. Right, so first up, I'm going to find theta over here. So I'm going to say that I know tan of theta is equal to the gradient. So theta therefore is equal to arctan of my gradient. What is the gradient of AB? It's 2. So that was 63,43, if I remember from the last one. Let's just double check. Arctan 2, 63,43, right? Correct. So there we have theta. Next, I'm going to find beta. So I'll say tan of beta, the angle of inclination, is equal to the gradient. Therefore, beta is equal to arctan of that gradient. What is that gradient? That gradient we see over here is -3. So I'm going to pop in that -3. Arctan -3. I find out that I get -71,57 degrees, right? So we know when it has that negative, what I need to do, just plus 180. So what's that going to be? 108,43 degrees. Just double check, plus 180, 198.43 degrees. Right, so now we have beta and we have theta. So I can say, therefore, alpha, the angle I'm looking for, must be equal to beta minus theta. What's my reason? Exterior angle of triangle. So remember that even though we are working in analytical, this is still a Euclidean reason, and Euclidean needs to be paired with their proper reasons. Anytime I make a mathematical statement in Euclidean geometry, I must have the acceptable reason as well. So now I'll just plug in what I know. Beta is 108.43 minus 63.43. 4's cancel. 105.45 degrees. Wow, that kind of worked out like perfect. Crazy. Okay, right. So my alpha is equal to 45 degrees. So that's how you'll find angles away from the x-axis, still using inclination of angle. So it's important to keep in mind the only thing that can really create angles in analytical geometry is inclination of an angle. So if you need to determine angles, most likely you're going to be using that. So stay tuned next for a video on just basic analytical questions, extra stuff that they might ask that you just need to keep in mind.